Hello everyone, welcome to this new video. So we'll be solving the problem height of binary tree. This is the very first problem of the series Geek for Geek problem of the day, and this question will be solving using the concepts of recursion. So we'll be using a one-liner solution as mentioned, and the company tags are like you can check here. This question has been asked by various companies, and also the topic tags. So this comes under trees, and yeah. So the question is all about finding the height of a given binary tree. All right. So that's what question says. Given a binary tree, find its height, and even it's a very easy question. So we'll be solving it with the help of recursion. So we'll not be using except this tag space, we'll not be using any extra data structure. All right. So how do we do it? We'll be seeing that with the this notepad. So I'll be illustrating this with an example. I hope the question is clear. So coming to the test cases. So why is this answer 2 for the very first test case? Because the 1 is at first level, 2, 3 are at the second level. So there are total of 2 levels, and so is the reason height is 2. Coming to the second example. So this is the very first level, this is the second level, this is the third level. So in total there are 3 levels, so that is the reason the height is 3. So we have got an idea like how are we actually coming to a conclusion regarding the height. So let us understand how recursion works. All right. So we'll be taking a very basic binary tree. So let us assume this is 1, 2, and 3, and this is 4, this is 5, and I'll be leaving this 3 just like that. All right. So the very first thing. So this is what would be given. This root will be given to us. All right. So once it's given, I'll be adding 1 to my answer. All right, I'll be adding 1 to my answer. The reason being because now we are encountering this. All right, now we are encountering this. As we encounter something, we can say that this would actually add an answer to me, like add 1 to my answer, isn't it? Because this is the root, that we are starting with. So I can assume that this will be actually contributing to my level or to the height of the binary tree. All right, so I'll be adding 1 to this, plus I'll be asking my left child, I'll be asking my right child, what are their individual heights? Okay, let us assume this is HL, this says HR. All right, let us assume 2 says that when one asks to 2, like its left child, what is the height of your binary tree? Let us assume it gives HL as the answer, and one asks 3, the right child, so what is the height of your tree? Let us assume it says HR. So I would add 1 to maximum of HL comma HR. Why is this so? Because 2 gives the answer as 2, right? Because there are 2 levels here, so 2 gives 2. 3 says it only gives 1. So let me indicate this with a different color. So 2 gives answer as 2. 3 gives answer as 1. The reason being 3 has no child. Alright, 3 has no child. So it is an individual level. It is a root with only like it is only having a one single level. So there are no childs to it. So it will be contributing only one level. So we'll be returning 1. And 2 says no, I have a child, I have 2 childs, left and right. So the total height including me would be 2. 1 plus, so this follows the same recursion. 2 asks its right child and left child. So 2 asks this right child and left child. So 4 would return. Okay. So I'll be writing this with another color as well. So 4 would be returning 1. 5 would be returning 1. All right. So 4 would be saying I do not have any child. So there's only one level that I am staying. So I'll be returning 1. 5 would say the same. It will return 1. And 2 at 2 the position is 1 plus max of height of 4 and height of 5. All right, and height of 4 is 1, height of 5 is 1, so total it returns is 2. That is the reason it is returning 2. All right, so 3 says there are no childs with me, there is no left child, there is no right child, so there is only single parent, single person, and that's me. I am the only person who is living here, so I'll be returning. So what does it return? 1 plus max of its left child. Let us assume it has h left and h right. All right, and what is h left? It is 0 because there is no left child to 3, and h right, that is also 0 because it has no right child, so it will only be returning 1. Right, so 2 would be returning 2, 3 would be returning 1, and this is max of hl. What is hl? 2. hr, that is 1. So this is 1 plus 2, that is equal to 3. So answer that 1 would be returning as 3. That's it. So the basic formula, the formula that it dilutes to is, so the formula is 1 plus max of height of left child comma height of right child. That's it. This is how it dilutes to. And the very base condition is that if we are encountering a if we are encountering a root which is not valid or which is null, so that is if the root that we are encountering is actually null, then return 0. All right, so then return 0. That's it, we are done. All right, so this is how you will be writing it. So once we encounter something that it's not valid, because 3 calls it's to its left, to its right, but it's going to return 0 because there are no childs to it. That is the reason. Even it's the case with the 4, it will call to its left and right, it will be returning 0, it will be getting the 0, and same is the case with 5, it will be getting 0 as their answers because there are no childs to them, so they'll be only returning 1 and 1. I hope it's clear. So that's very basic, and let us now go to the compiler and code this. So first we'll be doing the formulation. So I'll be returning 1 plus max of height of node left, okay, and height of node right. All right, and what if the node is not valid? If node equals to null, so in that case return 0. All right, if not, we'll be returning 1 plus the maximum of its left result and the right result, 1 plus to it. That's it. So let us run this code and check if it's working. Yeah, it's working. Now let us submit it. Fine, so it has passed all the test cases. I hope you people actually understood what I'm actually trying to convey. It's a one-liner solution, need not think much. So it's just a basic formula that we need to use and the basic observation that we need to see. So I'll be attesting this C++ code in the description, as well as the link to the PDF, or maybe like I'll be uploading this PDF in the Google Drive, and I'll be putting its link in the description. You people can actually see this for your better reference. Thank you for watching this video. Stay tuned.